Hello everyone, welcome to Expert Talk series. We have one more expert today to talk about very special recipe for wastewater treatment sites. If you know already that I'm Hitesh Vora, I'm a director of Great Plains Center of Excellence here at Oklahoma State University, and this is our way of putting expert in front of you so that you have more resources available to looking at energy efficiency and sustainability and grow your business, grow your partnership more. Right? Without further ado, I want to introduce our speaker today. I have Amrish here with me, which is basically come from all the way from India. Hold the mechanical engineering degree from MS University in Vadodara. More than 24 years of experience in several different aspects: chemicals, special chemicals, foods and home, personal care industries. His expertise also include capitalizing market trends, business development, managing, fostering partnership, developing new technologies, and so on. Right? He's a very much good expert on this. I wish he has a PhD degree here because what the work he done is more than a PhD here itself. However, he also helped build really a good working partnership with several industries, including L&T in US, large CPG account for P&G, and General Mills and Unilever for more than $30 million revenues also. He's actually representing Boson Alchemies. He's actually overseeing commercial and business functionality of the company, strategic business growth, new innovation, leading and negotiating significant bid and contracts, and also advising as a board member on merger and acquisition of this. He also has a partner, Milind Mankad. He's physically not here today, but he also comes out from various different background. He's actually MSc in physics, 20 years of experience in water and wastewater, solid wastewater treatments, hydrocarbon processing, upstream, midstream, both. He takes keen interest in metallurgy science and supervising R&D expertise and applied science of it, especially for the water solutions. So before he on board into the Boson, he was actually there on the Marcus, Germany. He's also supervised technical operation at Boson and is responsible for planning, coordinating, and executing all technical components of various objects. He also oversees laboratory analysis, treating, testing, piloting trials, and also processing analysis of water and wastewater. So without further ado, I want to invite Amrish to talk about water and wastewater treatments and what's the cutting edge going on and how we can lead these efforts into energy and sustainability side of it. So thank you, Amrish, for joining us.
Thank you, Hitesh ji, for the nice warm welcome and the introductions that you had given to us. It's a pleasure to be here, welcoming us at the Oklahoma State University campus, giving us this chance to present what we bring as innovative technology solutions to water and wastewater. My name is Amrish Mehta. I lead the efforts for Boson Alchemies. That's our company. We have multiple offices present in the US and also in South America. And I would be, presenting you with what we do in the water and wastewater treatment side of things. So without much of a delay, let me start with what we do. So basically, in terms of our company, we are industry experts or stalwarts from different industry background, and we created technology solutions for treating water and wastewater. So the company name is Boson Alchemies. If you know Higgs boson, the particle physics, the boson particle. So the name has been derived by the strengths of physics and chemistry. Alchemies is an older version of, when in the older ages, chemistry was known as alchemies. So we use the strengths of physics and chemistry to treat water. So that's why the company's name Boson Alchemies, and all that we do is an advanced oxidation of wastewater and water as a process. So we will go to the next slide. So in terms of water, as I mentioned, that we look at using cutting edge physics and chemistry to treat water. For us, this is a catalytic oxidation as a process. So we use catalysts. They are metal catalysts that we have developed to degrade compounds to do oxidation of, different types of pollutants and compounds that are present in water. So in terms of solutions and capabilities, we offer sustainability assessment services, consulting for certain programs like AWS. We do water management studies. We offer water and wastewater treatment solutions. We also offer zero liquid discharge solutions. We do utility water treatment. We do analysis of water, testing of water, and also do treatability tests on whether we can solve your water objective. So all this is something that we do. Now, in terms of our real strength, we basically solve issues with water and wastewater by understanding comprehensively what is present in water, whether it is the chemistry, whether the type of pollutant, the nature of pollutant. Once we understand that, we can treat it. We are not one-stop, shop for everything. We are not using general applications of solutions in wastewater treatment. There are many industries who does general, one solution works for all types scenario. We don't have something like that. We specifically target the pollutants and the chemistries. We understand them first. Once we know what is present in water as a pollutant, we know how to remove it. So it's a very targeted, very specified, a chemist-based approach to treat. So when it comes to water, we can treat water from city water sources, river bodies, groundwater, lakes, and then we give it to facilities. And when they produce wastewater from the facility, we can also treat wastewater and bring that back for reuse in the facility. So in a way, this slide actually tells you that we can treat all kinds of water, whether it is fresh water or wastewater. Okay, now coming to fresh water, we do ultrafiltration, reverse osmosis, we do basic filtration to remove organics from well water, we do water softening, we do, activated carbon filtration treatment, we have ozonation, ultraviolet treatment, also we do DI water generation, we have different types of water treatment that we can deploy. So that is something that we do in fresh water treatment. When it comes to wastewater, we have developed the technology using catalysts. These catalysts can actually remove and treat dioxin compounds, it can do toxic compounds, it can remove toxicity. We also can easily, effectively treat PFAS. And I'll repeat again, we treat PFAS. We destroy the PFAS compounds. We don't segregate or separate PFAS. The traditional technologies that are available, they can separate PFAS by using either carbon or use some kind of media to separate PFAS. So the pollutant gets transformed from one stream to another stream. It does not disappear. It does not get destroyed. So there are membrane technologies, there are carbons that you can use to separate PFAS. But how do you treat it? We can actually oxidize PFAS compounds. So if you have the RO reject, which has all the PFAS compounds in it, we can actually treat the reject of RO to remove PFAS. So we actually break open the carbon, the hydrogen and the fluoride bond. The F bond is the key bond where the PFAS compounds come from. So the perfluoroalkyl substances treatment is something that we can easily do using our oxidation process. So we also do domestic water treatment. So if you are looking at treating sewage and bringing water back for reuse, we can do that. And of course, our strength is treating industrial wastewater. So we do that treatment. We have done many installations across. We also do polishing. Sometimes people have compounds like there is phosphorus, remaining residual phosphorus in their wastewater before they go to city discharge. Sometimes there are some toxic metals that are left over before city discharge. We can treat that using, polishing unit, using the same catalytic bed. So in terms of our strength, because we use a technology which does not need a lot of power, it does not need a lot of energy usage. So, with our process, you can increase your profitability because you do not have the kind of OPEX that traditional systems have. We just have a pass-through bed that goes through the treatment, in a simple vessel, and the catalysts take care of the pollutant. So in terms of our strengths are, the amount of sludge, the amount of waste that is generated, secondary waste that is generated in our technology is very less. We can use more water with better quality. We can treat very challenging contaminants. Our plants are very simple to operate. It just switch on, switch off. There is no adjustment of, pH, or you don't have to do MLSS calculation. There is no FM ratio. There are no such complex things that are required. You don't have to see whether the bacteria is alive or dead. whether the bacteria can handle this wastewater or not, those challenges are not there with us. And we need the lowest footprint. So we do not need those large aeration basins and large anoxic tanks and a lot of storage and all. We don't need all that. We simply need a process tank which is having 3 minutes, 5 minutes, 10 minutes reaction time, and the water is treated. Coming to, as I mentioned, we basically are chemistry driven. So looking at chemistries, we can do treatment of chemistry which is aromatic compounds. It can be ammonia, it can be phenolic compounds and phenols, it can be cresols, it can be organics, it can be phosphates, sulfates and nitrates, the inorganic salts. We can treat dioxin compounds, we can do hydrocarbon treatment, anything that is non-biodegradable we can easily treat. It can be polymers, it can be colloidal silica. Many places you will see that the water has silica present in the form of bore water or groundwater. With that silica, if you have to treat the water, it's going to destroy the membrane, because silica is very, very abrasive for reverse osmosis membranes or nanofiltration membranes. So you don't want silica to pass through those membranes. So treatment of silica is very important. Similarly, if there is disinfection required, if you need PFAS compounds to be treated, if metals have to be removed, this is an area where we can actually help. Conventional and us, our technology we call it hydroxidation as a process, as a brand name or whatever you call it. So as compared to conventional processes where you have multiple steps, you have different coagulation, flocculation, aeration, anoxic, there are different steps that the water goes through. Whereas in hydroxidation, in our process, we have one single step which has the combined effects of all these different steps and processes. So it is very simple. It is more potent or more effective in terms of treating much challenging compounds. So because our brand name, or you can see the company brand or company tagline, that is, we call it hydroxidation. It is nothing but a catalytic oxidation. So which is a known process. Instead of using powerful hydroxides like hydrogen peroxide or using Fenton and all those processes, we have fused molecular oxygen in the catalyst. It replaces technology like Fenton. It helps you gets rid of hydrogen peroxide, because we use catalyst to generate the same molecular oxygen to degrade organic compounds. So when the compounds are degraded, it gets converted and destroyed into CO2, hydrogen, oxygen, nitrogen. It breaks that open into simpler molecules. So as in terms of how it works, typically we have a catalytic bed, a catalytic reactor, where we have the catalysts in the reactor, and we can use a DC power source or we can use it without the DC power source. Where the wastewater enters the catalytic reactor, it generates OH3 minus radicals. Those OH3 minus radicals are hydroxiles which degenerate the compound. Once the water is treated, it goes downstream. There is separation of solids by use of filtration, and the water is put in treated water tank. Further downstream, depending on the content of TDS, it can go to an reverse osmosis membrane, or it can go to evaporator, or it can be used for discharge to city, or it can go for gardening, depending on the end use. So that's how the process works. These are just the steps, the same process that I just explained. These are steps in writing. I'll be very happy, Professor Vora can, share the slides or share the slide deck. If there's any interest in, having a presentation copy, I'll be very, happy to share this with you all. So I would like to move forward with the basic, So this is another offset of the same catalytic technology, the catalytic oxidation process that we developed. That particular process is indiscriminate. It works on all pollutants together. It will work on the COD degradation, it will work on ammonia, it will work on any organic that is there. It will degrade. If there are any phosphate salt, any calcium salts, any nitrate salt, it will start degrading everything. In the real scenario in the world, what happens is people have specific problems. Like you want to only degrade COD, or you want to only take care of cyanide, or you want to take care of metal. Then we developed certain subsets of catalysts which are only targeted for certain organics. So we developed this set of catalysts only for certain types of problems. So here the process is the same. It does oxidation on the surface of catalyst. The only difference is these are formulated catalysts for different problem areas. For cyanide, there's a different catalyst. For organics, there's a different catalyst. For removal of sulfide, there's a different catalyst. For pesticide, it's a different set. So here, the beauty of this process is the water just passes through, and whatever target compounds that we want to remove, they will get removed at the outlet, and the remaining will remain on the surface of the catalyst. They'll get oxidized on the surface of the catalyst, and then when you introduce a regenerant, which is a conjugate of the catalyst type, when you introduce the regenerant, the targeted or the absorbed catalyst, the absorbed pollutants get transferred to the regenerant. So it's a very simple process. You concentrate all your pollutants in a very lean, small stream, and the water gets treated, majority of water gets treated and passes through it. So how it works, because, those who understand chemistry, those who understand the physics side of things, they will understand this well. It is a high surface area substrate on which we have doped the catalyst. And, when the water goes through the catalytic bed, it may have many pollutants like COD, BOD, color, turbidity, organics, nitrogenous compounds, metals. When it passes through it, the arrested compounds, they get arrested by the catalyst. It forms ligands on top of the surface of the catalyst. Only when the regenerant and the conjugate of the catalyst enters the catalytic bed, these arrested compounds are released in the regenerant. So this is how the technology works, and once your regenerant fluid is saturated with the compounds, it gets discarded. So as I mentioned, the CIC catalytic bed treatment is designed for different formulations. It can be for any of these formulations. It can be phenols, hydrocarbons, dyes, metals, halogenated compounds, produced water, oil and water emulsions, removal of ammonia. There are a lot of different catalytic formulations that we have developed. In terms of the operation, the CIC bed process is very simple. There is effluent feed, so there is a forward flow. There is a backwash in case there is any suspended solids in the water. There is a backflush. The backwash is basically where it releases any suspendeds that get captured and that get settled on the catalyst surface. We don't want the surface area to be blocked. During saturation, a regenerant fluid will come in, and this regeneration is where it will release the captured compounds in the regenerant stream. We have our pilot setups on the catalyst treatment. So we have pilots with 1000 liters per hour capacity, 200 liters per hour capacity. We have the oxidation process treatment with 1000 liters per hour capacity pilots that we develop. So in terms of advantages, as compared to conventional, our plants are ultra compact with less than 10% space that is required. We don't have any civil works. We don't use any bacteria, so there is no MLSS, no FM ratio, no biomass calculations. It is simple switch on, switch off. We don't have any manpower that needs, like skilled manpower to run the plant. All our plants are modular, so we don't have like large civil infra based installations which cannot be moved. You can install our plants anywhere. You can shift the plants any number of times. Our plants are delivered in 10 weeks time. 10 to 12 weeks is what we need to supply the plant. Everything is modular in our process. So in case you are looking for certain capacity now, you install only that capacity now. When you want to expand, you add more modules. You don't have to install all the capex and opex for the future. You install as and when you need it. Similarly, the sludge generation is much lesser. It is less than 70% sludge that it generates because we don't add anything to our process. The water goes through the catalytic bed and it comes out. We will remove pollutants and not add any food. There is no food to be given to bacteria or anything. So we are not adding any sludge in the system. So there are many other advantages. The plants can be fully automated. We take a very scientific approach. We start with lab trials, go to pilot if required, and then supply the commercial plant. The treatment is in minutes. It is not hours or days that it takes. So the plants are very compact. We can target multiple compounds together. So if you want to remove organics and metals, we can set up the catalytic bed in such a manner that both of metals and the organics can be removed. So we have treated many effluents. We have seen reductions in COD, reductions in BOD up to 95%. We can reduce silica, suspended solids. We can remove heavy metals. We have seen removal of phosphates and nitrates to an extent of 93%. So these are the efficiencies that we have achieved so far in our system. In terms of industries, every industry that you know of, right from food and beverage, oil and gas, agrochemicals, chemical, pharma, textile, pulp, paper, paints. I mean, you name the industry, it's a target industry for what we do. When we supply the plants, we have our own process systems that we design and supply. So you can see we supply DAF. For filtration, we use equipment like DAF and screw press, which is a continuous process, because we need continuous process in our type of plants that we do. All pH control, preparation of poly and dosing of poly is all automatic. All the skids for CIP and treatment is all that we develop in our processes. Ultrafiltration. So downstream, when you are looking at reduction of TDS and suspended, we design ultrafiltration, reverse osmosis plants for downstream. We work with all the reputed manufacturers like Suez, which was earlier GE, Hydronautics, Torre, Mann and Hummel, Pentair, DuPont, LG, these kind of manufacturers. We also have the capability of design ZLD systems. So these are using ME and MVRE systems. So when you're looking at evaporation of concentrated salts, that's where these things come in picture. We have facilities in India. We also have a facility that's coming up, in the US. It is a state-of-the-art lab that we are setting up. Right now we have set up in Cincinnati. Some cases, here are some installations that we have done. So this is one of the installations for an ink manufacturer. This is a Japanese company which makes solvent and water-based inks. So we set up a plant for them. So this is, this is a 50,000 liters of treatment that we do every day. So this is the facility. You see that little red block that you see, that is the plant. There's a whole facility that we have set up, but the effluent treatment plant is a very small, minuscule part of it. So this is what it looks like before construction of the shed. So the shed has now been installed, so it is an operational plant. We operate and maintain also this facility for the client. This is another plant we set up in the region of Jaipur in Rajasthan. This is in the western side of India. So this is a plant that handles plastic master batches, and we have treated the wastewater for this. These are the parameters you see on the screen. This particular plant is ZLD, so there is downstream recovery of all the water, and 91% of the water is brought back as reuse for the facility. It's a completely PLC operated plant. This is when it was in construction. The picture that you see on the screen is when it was under construction. So this is how the inside facility looks like. We are using all surface tanks. It's very nicely, very well maintained facility as a wastewater. This is a plant we installed for biodiesel. This is using, they have content of methanol in the effluent. We are dealing with this very high COD of 42,000 ppm, and we bring it to less than 300 at the outlet of our reactors. So you can see 110,000 liters per day treatment. We need only 2 reactors of 500 liters to treat the wastewater. So that is the beauty of the residual time that we need. We need very less time to treat water. That's why we don't need a lot of space. This is a vertical installation we did for a pharma company. They make sodium valproate salts, and it is a distillation process, and after distillation they have trace of the product in the water, in the wastewater. So we are removing and extracting the product, and it's 350,000 COD as feed, and we bring it to less than 1500, and this is happening with the product extraction. So we are also recovering the product and giving back to the client for reuse in the process. So there are installations we have done for animal food. This is a plant in the in the southern India in Andhra for animal food. Then we have installations in crop manufacturing for sulfur chemistry. We have done treatment plants. We have done river body filtration systems like these, where the water is drawn from the river and there are certain organic impurities in that to treat. So this is a continuous treatment using CIC catalyst for river body filtration. We have done cooling tower treatment. So this, you see the pictures on the screen. You can see the basin water of cooling tower with SRB bacteria. So there is Legionella and sulfur reducing bacteria. So moment you have the SRB, the water turns black. So we have treated that water with, you can see the parameters. If you understand the parameters, there is a high COD and high hardness which we reduce in our process. So here the delta T of heat transfer is impaired drastically because of these bacteria present. So we can treat such chemistries very easily. We have done treatment of ethanol plants. So this is a grain-based distillery where they typically use a CPU for treating the ethanol wastewater because it has acidic effluent nature and it has very presence of organics with very low pH. So normally they would want to treat it using a CPU with aeration and anoxic tanks and all that. It needs a lot of infrastructure and a lot of space. With our process, we just need the CIC bed followed by UFRO and we can recycle the entire set of water. And the system is right on your screen. That's all we need. We don't need those large civil tanks and all. These are some cases we did some trials for customers. So this is an esterification effluent that we did for customers. So this is what we have done for a customer here. We've done effluents in food and beverage. So this is a caramel color and it is used in beverage industry. So we have done treatment of this as wastewater. This is how the treatment of the wastewater looks like that we have done for the client. So this is a similar wastewater that we done for another effluent of food and beverage company that we have treated. So I think that pretty much covers what we do. So I hope this presentation was informative enough. In the limited time that I had, I could present out whatever we do, what technologies we use. So I hope this was informative. I would be very happy to take any questions and any follow-ups that you would want me to answer. I'll be very happy to take them on. Thank you so much. My name is Amrish Mehta, signing off. I'll ask Professor Hitesh Vora to have the session open for any questions. Thank you.
Thank you so much, Amrish, for a wonderful presentation. I think, as I understood, I think there is lots of eye-opening case studies and also very nice, clever way of playing with the chemistry and physics. Obviously, like playing with science is always fun, and finding that fine-tuning of that chemicals and getting that output and actually getting that applied side of it is very wonderful to see the end-to-end results also. So wonderful. I think our stakeholders should take this opportunity to the next level and try their best to find out opportunities where this can be implemented, right? So the floor is open for you. This video will be posted in our YouTube channel. Please ask the question you have, or you have my email address, or you can come reach out to our center as well as reach out to the Amrish. If you have any question, any wonderful ideas, or maybe collaborating with us, or maybe you have some opportunity to expand more, please, more than happy. And please explore these possibilities into the next level. Thank you so much. Thank you for attending Expert Talk series. Have a nice day. Bye-bye.